Thanks for joining. Good morning. We're going to talk about irrigation intelligence. What Manna calls irrigation intelligence is knowing your actual field water consumption. That will be the topic for today. My name is Hovav Lapidot. I'm the CEO of Manna. Happy to be here with you guys. Let's start with why irrigation scheduling matters at all. So in a nutshell, or in a snapshot, we know there's a lot of water on Earth, but if you actually look at it in proportion, the fresh water, not salty water, is only 2.5% of this huge amount of water, out of which only 0.5% we can actually access and use for agriculture, industry, and domestic purposes. From this 0.35% is used in agriculture. So that's not a lot compared to what we have on Earth, or what we think we have on Earth. So we all know we have to be more effective in the way we use water, obviously at home, but definitely in agriculture. Now, there are many things you can do to improve your irrigation efficiency, like using modern and sophisticated irrigation equipment or systems. But irrigation scheduling, meaning the decision of when and how much to irrigate, is very important as well for the sake of improving your water use efficiency. We all know that under irrigation is not good for the plants for obvious reasons, and therefore for the yield. But over irrigation is not good either for many other purposes or many other reasons. So finding this elusive optimal point in between of when and how much to irrigate to perfect your yield and water usage is what is called irrigation scheduling, and that's why it's so important to work on. One of the maybe most popular or fundamental part or practice in irrigation scheduling is called evapotranspiration. And we're going to talk about evapotranspiration today, even though there are many other practices or tools to be used when you come to schedule your irrigation. Using evapotranspiration is actually giving back to the crop the amount of water that it used or lost since last irrigation and until your next irrigation if you're planning ahead. So it's actually, if we could just measure how much water our field lost or used, then we could replenish it. The term evapotranspiration is actually a combination of two different parameters. The first one is evaporation, which is the water that is being lost from or being dried out from a wet soil. And the second part, transpiration, is the water that flows through the plants or through the crop, from the roots, up the stems, and out to the atmosphere through the leaves in the process of the photosynthesis. So if we could evaluate or measure this water usage, then we could make our irrigation decision much more informed or improved. The short term is ETC, or evapotranspiration crop. C stands for crop. And as I mentioned, it is based on two different parameters. Now, if we look at the season of most irrigated crops seasons, at the beginning of the season, maybe the water that is being lost through evaporation from the soil is more dominant than the crop, because the crop is still young and very low on vegetation. But really quickly, the crop develops, and during most of the season, the dominant outflow of water is coming out of the transpiration or from the crop itself. An interesting fact is that crop transpiration correlates directly with the crop vegetation or the crop cover. The more leaves, the more water usage or the more vegetation. So that's a fundamental understanding going forward for today. But in any case, when you try to calculate the crop evapotranspiration, question is, can it be measured? It's something that we cannot even see, not to mention measure. How can we know how much water is going out of the leaves or going out of the whole field? That's a good question. It can be measured. Before we show how, let's go a step back to ag school and remind ourselves of this simple evapotranspiration formula. In order to calculate this crop evapotranspiration or field water consumption, we need to have two factors. The first one is ETO, which is a weather parameter representing the reference daily evapotranspiration. You can take it from either a online virtual virtual station service, or from a local weather station, one that you install yourself, or a nearby station that you can access. The second parameter is KC, that is actually crop coefficient. In order to calculate how much exactly my crop how much water it uses, it needs to be factored to the specific crop and the specific time during the season. Obviously, a field of tomatoes will not transpire the same as almonds or corn. And it also reflects the time of the season, whether the crop is developing or in a vegetative mode or fruit development, etc. So you can get those estimated crop coefficients per crop by using protocols or publicly available tables or articles. But in most cases, these are outdated or well created or evaluated a long time ago on a different variety that you use today. And in any case, it is not representing the actual conditions of my crop in my field today. It's a theory, but not the actual conditions in the field. So what we are proposing here in Manna is a different approach that is actually observing the actual ETC using remote sensing or using satellite imagery. It provides the actual crop coefficient, meaning my own field, my own crop, a crop coefficient, and we use high resolution and high frequency satellite images, so near daily measurement or observation of your field. And with the right algorithm, it can calculate your actual field specific and daily field water consumption. That's what we're presenting today. What you see on your left is a screenshot, and we'll go through more of these going forward. This is just a representation, or maybe a graphical explanation of how it's done. As we said, the water consumption correlates with vegetation. I'm sure you all know there are very popular ways and proven ways to measure vegetation density. One of the most popular indices to do so is NDVI, which represents the density of vegetation in every pixel of the image. In this case, what we're seeing is a cornfield analyzed for vegetation or for NDVI, with the red, orange, yellow colors represent thinner, less vegetative crop. As we can see here, it gets up to the knees, and there's more soil rather than a crop or vegetation. And in this area of the field, there will be a lower water consumption. Light green will represent more vigorous vegetation, or more thick, more leaves, more crop, waste high crop in this example, and mid water consumption. And the dark green, very lush and strong vegetative crop that will use more water. The methodology that we propose takes those insights or those measurements of every pixel and put everything together in an aggregated view. So we look at the entire field and provide the entire field's water consumption as actual as can be. In order to do so, just to give you a hint or a little bit of under the hood what's going on, we use 4 different types or constellations of satellites. The first 3 here are all multispectral satellites that provide multispectral images in different resolutions and revisit time. So Sentinel-2 is a very popular satellite. It provides a 10 meters per pixel resolution and a revisit time of 5 days. PlanetScope is the premium constellation we use as part of the service, and it provides a daily revisit time and a 3 meters per pixel resolution. It is important to say that while the satellites of Planet will visit every field on Earth or every field in the Manna service every day, not every day it can provide an image because of atmospheric conditions like clouds, like fog, etc. But the model, the evapotranspiration model provided by Manna can do even in an image every 5, 6, 7 days and provide a good results just as well. The fourth one on the right is a completely different technology of observation, of Earth observation. It uses radar rather than imaging, and the benefit of doing that with radar is that radar can penetrate clouds. So in very cloudy areas, we can still get the vegetation information that we need in order to provide this crop evapotranspiration or crop water usage to the users. This whole capability or model was tested and verified, first of all, in a correlation test in which we compared the satellite provided ETC to ETC measured in the field. The way you can measure ETC in the field involves a very sophisticated, heavy scientific equipment, so it's not something you can do on every field, but we use this equipment in order to do that over multiple crops, about 10 growing seasons, 4 stations of this equipment, and many different satellites in order to get a big data set. And as you can see, there is a very strong and high correlation between satellite provided ETC and the measured ETC in the field, which makes it very high confidence and high accuracy of our solution. It has also been tested or used by thousands of growers worldwide. You see here a dot for every field we have in the system, so quite a significant presence already. A little bit of screens, and then we'll do questions. These are screen grabs from the application itself. The data is provided by a web application, so you can access it either from a laptop or desktop or any mobile device with an internet connection and a web browser. Okay, so it's very simple to use. What you see here is the irrigation scheduling screen. In this example, we have a field with 2 different valves. So the system will give you data for every valve if you set it up this way. So you can schedule irrigation even to the valve level. It shows your previous irrigation, your next recommended irrigation, and what we're talking about today is actually this block here, the field water consumption. Yesterday, this crop or this field consumed 4.3 millimeters, and if you want the system to aggregate a few days, you can set it up. So currently it shows the last 4 days, the total water consumption was 14.9, but again, you can change it to any number of days you wish. And as you can see, there may be some small or sometimes larger differences between different areas or different zones in the field. Because the crop may be different, maybe there are different varieties, different planting dates of different valves. So you can be very, very specific and get the accurate information even for the zone level. That's another look of a more details if you want to see more of a calendar view. So you have the ETC or daily ETC for every day. Here are the scheduled irrigations and observed or forecasted rain events. Altogether present the soil water content around the root zone. The full bar it means that the soil is in, or the field is in field capacity, and this line of readily available water is the line that you don't want to go below, and anywhere in between you schedule the irrigations. Another functionality or ways to use those satellite images other than calculating irrigation scheduling is use them for crop monitoring, crop development monitoring, and identifying anomalies and potential issues so we can respond to them and save a potential yield loss. As I mentioned, daily images or near daily images can help you do that on a very frequent manner. In this example, we show there are 2 different maps. One is crop vegetation, again, the density of vegetation, and on the right-hand side, crop wetness, meaning the water uptake or the water potential in the plants, not the soil, but in the plants. So in terms of vegetation, we see a little bit of anomaly here in the middle of this zone 2. And in terms of wetness, this looks like a potential either an irrigation or irrigation uniformity issue or a water uptake issue of another kind, but at least it shows you the variability of the crop water uptake or the ability of the crop to take water from the soil. Another example from pivot, center pivot irrigated field. Again, you see a little, so little, but quite a significant crop anomaly in vegetation here in between 9 and 11 or 9 or 12 o'clock of the pivot, and the same is shown here in the vegetation, in the crop wetness, sorry. In pivot irrigated fields, this map is very useful to find problems with the nozzles or with the equipment. In many cases, in many times, you see it very clearly. That was it in terms of content. We wanted to keep it short and leave enough time for questions. So if you have any questions, you can either type them into the Q&A box or unmute and share them with me. I'll try to get